You want to know how this muffin ends up here? Well, this documentary shows the process of how food travels through the digestive system and how it affects each organ. The digestive system is the mechanical and chemical breakdown of food in our system. The digestive process begins in the mouth, where our muffin must be ingested and is slowly broken apart by our teeth using mechanical digestion. The grinding of the molars and the action of our tongue moving the food around the mouth helps to break down the muffin to even smaller chunks. Human teeth have a supply of blood and nerves which allow a certain sensation when chewing food, telling our brain to start the digestive process. Chemical digestion begins as the saliva from the salivary glands mix with the chewed food, which contains amylase, which is an enzyme that helps break down carbohydrates. Complex carbohydrates such as starch or glycogen will be broken down to simpler molecules and glucose through the salivary amylase. Amino acids will help break down the protein easier, and the fatty acids in fat contain lipids, which is an oily compound that is an essential part of living cells. As the food is being masticated, orange juice was added to make it easier for the muffin to go down the esophagus. The muffin was broken down into what we call bolus. The esophagus connects your mouth with your stomach. The pharynx is the connective tissue located at the front of your neck that moves the food from your esophagus through to your stomach. The epiglottis closes the windpipe so that it will prevent choking when you're swallowing food. The food bolus is pushed through the epiglottis into the upper end of the esophagus. Peristalsis are the waves of muscle contractions that slowly pushes the food down the esophagus into the stomach. There is no digestion in the esophagus, however the esophagus secretes some mucus as lubrication for swallowing. As peristalsis pushes the food down the esophagus, the sphincter muscles at the top of the stomach relaxes and lets the food bolus through into the stomach. Sphincter contracts to make sure the food does not re-enter the esophagus. Gastric juice, which has a pH of 2, contains HCl and a mixture of enzymes that digest protein enzymes are mixed with the food bolus. The strong muscles in the muscle walls churns and mashes the food together. This mixing action in the stomach produces chyme, a watery mixture or partially digested food. The stomach secretes hydrochloric acids, pepsin, trypepsin, and mucus. Mucus is secreted by the stomach lining cells so that it can protect the stomach lining against the stomach acids. The sphincter is located at the bottom of the stomach where it controls the chyme passing through the stomach into the small intestine. Now we move to the small intestine, which completes the digestion and the food absorption before moving into the large intestine. It is divided into 3 different sections: the duodenum, the jejunum, and the ileum. The chyme from the stomach is pushed through the top part of the small intestine, the duodenum, where it is mixed with the digestive juices and the digestive enzymes from the pancreas. The intestinal walls grab onto sugars, amino acids, fatty acids, vitamins, and minerals. Villi is a lining in the small intestine that have many absorptive cells to absorb nutrients and other things that the muffin contains. The surface area of the villi has microvilli that increases the surface area of the small intestine. Therefore, there is more room for absorption of the food. The pancreatic juices contain sodium bicarbonate, lipase, amylase, and proteases, as well as bile, which is produced in the liver and stored in the gallbladder, are also both mixed with the chyme in the stomach at the duodenum. The pancreatic juice contains amylase that hydrolyzes the polysaccharides into disaccharides. The chyme is also mixed with the intestinal juice, which contains enzymes such as maltase, lactase, sucrase, which are named for the sugars they break down. These disaccharides help the digestion of disaccharides. Therefore, the digestion of carbohydrates in the small intestine is complete. As the chyme moves through the intestine, the duodenum and the jejunum absorb the chyme's amino acids, carbohydrates, lipids, calcium, and iron. There is also peptidase that splits up proteins into peptide fractions, creating amino acids. The carbohydrates, which begin as starch polysaccharide, are then digested into monosaccharides for absorption. The ileum absorbs the chyme's bile salts, vitamin B, and water electrolytes. The sphincter is located at the bottom of the small intestine, which prevents the food that passes through the large intestine from re-entering the small intestine. Now we are almost done, but we need the food bolus to go through the large intestine. The large intestine has no villi or human digestive enzymes. However, it is able to absorb water, some vitamins, some fatty acids and minerals, sodium, and potassium. The large intestine also has a number of mucus-producing cells, whereas the mucus that is secreted by these cells help to hold the feces together. During the digestion in the large intestine, little protein and complex carbohydrates still remain, fats are gone, but some fatty acids remain. Remaining vitamins are absorbed. Minerals such as sodium and potassium are absorbed, and any excess water from the small intestine is absorbed in the large intestine. The food is then defecated into the toilet bowl as the muscular contractions in the rectum push the feces out of your body through the anus.